lesson is about inverses. And the inverse relation of a function switches the x and the y of a function. So the input and output. So we know how the function tells us the dependency between x and y. If I give you x, you give me y, right? The function tells you that rule to go from x to y. The inverse will do the opposite. You give it y and it gives you x back, right? So that's the inverse. You do the opposite. So if I have the data points, determined by the function f of x, the data points for the inverse function f negative 1x of x. Oh, I didn't talk about this. This is important. So the notation that we use to identify the inverse function is just the same letter that we use for the function with the negative 1, power negative 1 on top. Doesn't mean that it's a negative power, it's just a notation to indicate inverse function. Okay, so if I have data points for my original function x to f of x, for the inverse one, I need to switch those data points. So my y becomes my x, and my x becomes my y. So instead of 0.13, I will have 0.31. And instead of 4.6, I get 4.6. 6.4. 6.4. And then 6.8 becomes 8.6. Right? You see what's happening? The original function gives you x to y, and the inverse gives you, for that value of y, you get x. So it inverses the relationship, the dependency. Questions about this? Okay. So let's try the second one. We have the data points for the original function f of x, right? We have 3 points, x, y for each point. So let's write down the points for the inverse function. What will be the first one? 5, negative 4, correct. And then what would be the second one? 6, 0. And the last one? Negative 1, 1. Very good. So the relationship is reversed. Questions? Okay. So when instead of the data points, we have the equation for the function, right? This is what we need to do to figure out the equation of the reverse function. Okay, so I'll stop the recording for 1 second. Different, so we don't forget. Okay, so I have the equation for my original function. What I'm going to do first is I'm going to switch y and x places. So I'll just rewrite it as x equals negative 2y plus 5. So I'm switching x and y. Now I'm going to solve for y, because that's what we usually do, right? We solve for y. Y equals, that's my function, the new function. So I'm going to do the same steps. Minus 5 on both sides. Right? I'm solving for y, so let me use different color. Right, so minus 5 on both sides gives me x minus 5 equals negative 2y. Now to solve for y, I need to divide by negative 2, both sides. So I have y equals x minus 5 divided by negative 2. This is my answer, just to make sure that we all understand this is the reverse function. Let's put that negative 1 on top of the new y. And that's my final answer. Questions? So what I did is I rewrote the original but switched y and x places, right? Switch them. Then I solved for y, and then I put my negative 1 on top to indicate that this is actually the inverse of the original. Questions? All good? Okay, so let's try the second one. Should you try it by yourself? By yourself? Okay. Right, so I think everybody is doing very well here, so I'll just write the answer. Is it okay or should I work through it? Okay, let's work through it. Okay, so the first thing that I do is I replace the x and y places. So I put x equals 4y plus 3. I just switched x and y. Now I'm solving for y. So minus 3 on both sides. X minus 3 equals 4y. Don't forget I'm solving for y. Okay. Now I divide by 4, divide by 4. So what I have is y equals x minus 3 over 4. So I can almost leave it like this, except in the original we had f of x, not y. So let us rewrite, right, so that it's in the original terms. Like this. F of x equals x minus 3 over 4. And then the final touch is to put negative 1 on top so that we know this is actually reverse, not the original one. Right? So you can leave it like this. Yes?
When writing out the equation, can you just put x equals 4 f negative 1
Yes.
plus 3? And do
You can do it,
else?
yes, of course. Also, you know, sometimes if you have like multiple choice on SOL or whatever, right? Sometimes they don't leave it in this form, but write it in the standard form. So if I simplify this expression, see how I have a numerator x minus 3, I can separate it into two fractions, right? So I can write x divided by 4 minus 3 divided by 4, right? And then even farther, you know, x divided by 4, I could write as 1 over 4 times x minus 3 fourths, right? So this could also be the answer, one of your multiple choices, right? Because this is the standard form for linear function, if you can see. There is the coefficient, x, and there is the constant. Right? Just make sure that you know how to do this. But for us, I think both forms are good, right, Mrs. Osborne? We don't care, right? Right. We don't care.
Oh, unless it has to be simplified and you don't simplify it.
Unless we say simplify. Okay. If you say use standard form, this is the standard form. If you don't, this is just fine. Questions? Okay. So let's try the next one. Okay, let's do one together and then one by yourself. Okay, so what do I do first? Can I
Switch x and
switch x and y. So x equals 3y minus 1 over 2. Now what do I do?
Multiply by 2.
So I'm solving for y, so I'll multiply both sides by 2. And 2x equals 3y minus 1. Now what?
over 2.
Add 1, right?
Sorry.
Add 1 on both sides. And now what? Divide by 3. You want to use like a separate, different color for whatever you are trying to solve for, right? So you don't forget. Otherwise, you go back and forth, doing and undoing, and just use different colors. But we always solve for y. Okay, so now this is my either like this, or if I want to write it in the standard form, I'll write 2/3 of x plus 1/3. For us, either way is good. Just don't forget to put that negative 1 on top so that we know that this is inverse. So there is no confusion. We had the original function and now we have the inverse function. Both answers are good. Questions? Okay, try on your own the next one. So what is the first step you? You got the question, so walk me through it. First step? I'm switching x and y, right? So x equals negative 5y plus 3 over 4. Now what? I'm solving for y, remember? So what do I do? Multiply by 4 to undo that denominator. So 4x equals negative 5y plus 3. Now what? Huh? No. I'm getting y, right? So minus 3, right? Okay, so negative 5y. That's why it's so useful to do this in different color, because so you don't go like back and forth. Okay, so 4x minus 3. Now what? Divide by negative 5. Both sides. So I have y equals 4x minus 3 divided by negative 5. I can leave it like this, or I could also rewrite in standard form, which is negative 4 over 5x plus 3 over 5. Right? Everybody see how I did this? Okay. And so also we put the negative 1 on top of y, just so we know this is the inverse function. Both answers are good. Questions? Good? Okay. So let's do the next one. So here it gets a little bit more complicated, just a little bit. We have squares to worry about. So the first step is exactly the same. I'm just rewriting, switching x and y places for x and y. So x equals 2y squared plus 2. Don't have to use y, you can use f of x. It's just easier for me to write. So now I need to solve for my y. How do I solve for y? Minus 2 on both sides. X minus 2 equals 2y squared. Now what? Divide by 2. So now I have y squared equals x minus 2 over 2. Yes, now I can square root it, right? So I'm solving for y. So I'm going to square root both sides, and I don't forget what? Plus and minus, reverse. Right? So square root of y squared gives me what? Y, and then plus minus, and then just leave the x minus 2 over 2 under my square root. That's it. That's my answer. Well, that's my answer, but let's rewrite it in the original notation. So instead of y, I'll use f of x. F of x is my negative 1 on top, so I know it's inverse, equals plus minus square root of x minus 2 over 2. This is the final answer. Questions? Easy, right? Okay, so just like a side note, you know we said that inverse function, right, inverse is the dependency. So instead of from x to y, I go from y to x, right? Is this a function? Is this new dependency a function? No, why is it not a function? So my original function is a function, right? What's a function? Remember what a function is? Right, we have a dependency, right? So we have dependency from x to y. Like we can graph it and everything. Remember how we talked about properties of graphs? And we said some relationships, some graphs are functions and others are not. Right? So what does it mean the relationship is a function? Remember? For every single x, there is exactly only one y. There cannot be two different y's for one x. Remember that? The vertical line test that we did, remember? So the original function here is a function. What about the inverse? Is it a function or not? No, right? Because for every x that I choose, I will get how many different y's? Two different y's, one with the plus and one with the minus, right? So the inverse is not necessarily a function, right? And let me stop it. So let's continue with our examples. Oh, do this one on your own, actually. The next one, power. Okay, so the first thing the same, right? Everybody got this. We switch x and y. So I put x equals negative 3y to the power of 4 minus 9. And then we're solving for y, right? So everybody got the first few steps right. So I do plus 9 on both sides. I have x plus 9 equals negative 3y to the power of 4. I'm solving for y. So I divide by negative 3 both sides, and we are Most of us are here. X plus 9 over negative. Everybody is good here, right? To this point. So now how do I undo the power of 4? We can square root it. It will take us few steps, like more steps to solve. So let's just think. 2 to the power of 2 is 4, right? Square root of 4 is 2. 2 to the power of 3 is 8. Third root of 8 is 2. See how I'm undoing the operation, the exponent, to take in the root of the same degree. 2 to the power of 4 is 16. What kind of root do I need to take of 16 to get 2 back? Fourth root, right? You see how I'm undoing my operation when I take a number to the power of something? I need to take the root of the same degree to get my original number back, right?
Would you change it to x minus 3? Or would you
Oh,
keep
yeah,
it
we
as-
can simplify, right? Let's just worry about it.
Yeah.
So to undo this power to get my y back, right, I need to undo the operation, this exponent. So what I need to do is to take fourth root of this. But I need to do this on both sides. See what happened? Right? But because this exponent is of even degree, just like we did with squares, we need to put that plus minus. Don't forget about this plus minus. It's only for those even exponents, right? Because the even exponents will eat up the sign. The next one, similar to the one before, quadratics, just a little different form. So let's do this one on your own together, and then the next one on your own. So the first step again, same as before. I just switch the x and y so that I don't forget at the end. Okay, so first I switch the x and y. So x equals 2 minus y to the power of 2. Now I need to solve for y. So what do we do? How do we solve for y? Remember, I'm solving for y.
Square root.
Yes, because I have a perfect square on one side. To get rid of that perfect square, I just take the square root of both sides, right? So square root, and then what I don't forget? Plus minus. Every time I take square root or any kind of even root, plus minus. So the square root of the perfect square cancel out. So I have 2 minus y on one side, and then just plus minus square root of x on the other side. Still solving for y. So what do I do? How do I solve for y now? Subtract 2 on both sides. So minus 2 plus minus square root of x equals negative y. And finally, how do I get rid of this negative? Divide by negative 1. Right? So y equals, well,
2.
yeah, so just 2 minus plus square root of x. And when I'm ready to what is it? Circle, right? I don't forget to put the negative 1 on top of y to indicate that this is inverse of the original. Right? Don't forget to put it. Questions?
We get marked off.
If what?
If we leave plus or minus alone.
Well, what do you mean here?
Yeah, because you did minus plus.
Oh, it doesn't matter. Yeah, just some of you got confused before when I didn't switch it, but it doesn't matter. It's either plus or minus, right? Either minus or plus. Two different solutions. Okay, questions? Okay, let's do the next one on your own. Right? Should I work through it or should I just do the answer? The answer? Okay, so let's do the answer. If something doesn't look right, then we'll solve. Everybody got the same answer? Okay, good. So, next one. Okay, again, same process, different exponent, but we know how to deal with it. So the first thing to switch the x and y. So x equals y to the power of 3 plus 64. And now I want to solve for my y. So what do? How do I solve for y? Minus 64 first to get rid of that hidden fruit. Okay, so x minus 64 equals y to the power of 3. Now how do I solve for y? Yes, cube root, both sides. So on the right, the cube root will cancel the exponent, so I have just y. And in the other side, I just keep that cube root. And do I need to put plus minus in front of my cube root?
No.
No, why is that?
It's an odd number.
Odd number, right? So if I have square root of 1, it's plus or minus 1 because both 1 square is 1 and negative 1 square is 1. But if, well, that's wrong. You see, right? Square root is always positive, so it's, shouldn't do this. Right? Since both square root of 1 and negative 1 is 1, so when I have the equation x squared equals 1, I need to include both positive and negative 1. Right? But if it's about cubed roots, so x to the power of 3 is 1, 1 to the power of 3 is 1, but negative 1 to the power of 3 is what? Negative 1, right? That's why when I solve this kind of equation, I only have one answer. Right? That's why we don't do the plus minus here. Okay, so, yeah, we're done. All we need to do is circle and then put the minus 1 on top. Oh no, let's do this in, formally. So instead of y, I'll use g of x, just because that was my original letter, right? So g with the minus 1 on top equals third root of x minus 64. So that was my final answer.
So 64 does not come back at all?
No, because it's, the whole thing is under the root. Questions? Okay, do the next one on your own. So the first thing that I do is what? I switch the places x and y. So x equals 2y to the power of 3 minus 16. Now I remember that I'm solving for y, right? So I do the plus 16 on both sides. On the left I have x plus 16 equals 2y to the power of 3. That's it. So now how do I solve for y? I need to divide by 2 both sides. So I have y to the power of 3 equals x plus 16 over 2. And now, because I want y by itself, and right now I have y to the power of 3, I need to undo this exponent. To undo exponent, I need to take the root, right? Cube root on this side, and then cube root on the other side as well. Right? So the exponent and the root cancel out on one side, so I have just y, and on the other side I can't really do much, so I just leave everything as is. So this is my answer. I just put negative 1 on top to indicate that this is the inverse of the original. Or, as some of you did, you simplified the expression under the root, you separated it into two fractions. So it's x over 2 plus 16 over 2 is just 8, right? And then I still have my third root. So I can also write it like this. I can also write it like this, 1 over 2x plus 8. Same thing. Right? You see half of x like this and then half of x is pretty different. Right? All good? Okay, so let's try another one. Here we have the radical. Okay, so first I switch x equals square root of y minus 4. We do this just so we don't forget the end, because that's how, the standard way. So for SL, you are ready to see those multiple choices. Okay, so I need to solve for y. What do I do? I need to get rid of this radical. How do I get rid of that radical? I square it. That's right. So just square both sides. So x squared equals, and then this whole thing squared. And the square of the square root cancel out, so that I have y minus 4 on this side. And x squared is just x squared. Right? Now I can solve for y easily. What do I do? Add 4 to both sides. So x squared plus 4 equals y. That's it. So just put my negative 1 on top and circle the final answer. To indicate that this is the inverse of the original. That's it. It's just notation. Just to show us that it's not the same function. Questions? Good. So the inverse of the square root is the quadratic, right? Also kind of intuitive, kind of the opposite, right? Okay, so the next one, try it. Try by yourself. Okay, I'm going to just write the solution just in case. Yes? That's it. Questions? Great. Next one. Just a little scarier looking, but everything is the same. Okay, so switching x and y just because, so we don't forget. Now we need to solve for y. So what do I do? Somebody who doesn't speak usually. Who doesn't speak? He never speaks. Jose. What do we do to solve for y? What do I do to solve for y? Subtract 5 from both sides. So x minus 5 equals cubed root of y. How do I solve for y now? I do what? I cube everything. So x minus 5 cubed and the cubed root of y cubed. The cubed root and the cube cancel out. So I have y equals x minus 5 to the power of 3. Done. Except I want to put the negative, the minus 1 on top. Yes.
Why would you cube it?
Why would I cube it?
Why would you?
Oh, in the beginning? Because then, okay, let's look at this. If I took cubed root of y plus 5 and cube it, what does it mean? It means this whole thing multiplied by itself 3 times. So I would have to FOIL it. Plus 5 times the same thing. Plus 5 times the same thing. You see, I would have to FOIL it, and then I have some ugliness there. Right? It will not cancel out nicely. Right? What I want to do is to just cube these parts so that I have the cube and the cubed root cancel out. That's why I want it by itself. Right? And this is the same. Remember how when we wanted to, like when we have equation like this, x squared minus 1 equals 3. Right? We don't take the square root of this and that, right? Even though there is this perfect square, I don't do this. Right? Because for me to cancel out the square, I need it by itself first. So first, I I put it right here and then I square it. I mean square root it, right? I want that perfect square by itself, same weight, because this doesn't help me. Because it's very hard to simplify this. Same way, before I square it or cube it or do something to it, I want that radical by itself. Otherwise, it's something ugly. Right? Make sense? Didn't make sense. Any other questions? Okay, so no. Doesn't help. Okay, so let's try the next one on your own. Okay, let's solve the next one. Okay, so what do I do first? First thing, switch x and y. So x equals cubed root of y minus 2. Now I'm solving for y. I'm solving for y. I want y by itself. So what do? I first plus 2 on both sides because I want that radical by itself. Otherwise I cannot get rid of the radical. So x plus 2 equals my cubed root of y. So how do I get rid of the cubed root? I cube it, not cube root it, right? To get rid of the root, I need to use exponent because exponents cancel the roots. Roots cancel exponents. So I cube everything. X plus 2 cubed equals y. Right? Questions? Too easy? It is pretty too easy. Okay. So if I want, question for you. Question. If I wanted to simplify it, do I distribute 3 in? No. What does the power of 3 mean? When I do 2 to the power of 3 is 2 times 2 times 2. What is the power of x plus 2 to the power of 3?
X plus 2, x plus 2.
X plus 2 times x plus 2 times x plus 2. The number multiplied by itself 3 times, right? So if I want to simplify it, I would have to FOIL. Right? Don't distribute the power. No, we don't want to do FOIL, but just don't try to simplify it and do it incorrectly. If you want to simplify it, do it right. Don't distribute the 3, right? Yeah. If you don't ask, don't do it. If you do it right. Oh, and by the way, yes, so don't do this. The final answer should use the letter from the original equation, right? So not y, but f. F of x minus 1 equals x plus 2 to the power 3. So this is the answer. Use the original letters. That's next thing. Questions? No? Good. Okay. So, the last portion of today's lesson, graphs. So remember the original function, right? We have the original function, we don't have equation, so we are not going to try to find the equation for the inverse. All we want to do is to graph the inverse. So if I look at this original function, f of x, and I look at the xy points, right? I'll just choose any point, any important points. For the line, how many points do I need? 2 points. So I'll just choose nice ones. This one, the x-intercept and the y-intercept are nice. Nice enough. So 0, negative 3, and then 6, 0. So if I inverse it, what will be my corresponding inversed points? Negative 3, 0, and 0, 6, right? Correct? I'm just flipping the x and y, switching them. So now let's plot these 2 points. Negative 3, 6 is, negative 3, 0 is right here, and then 0, 6 is right there. No, not right there. There's something wrong. Here. Right? And then I just connect those lines. That's all I need to do. Not perfect, but close enough. So this is my inverse function. So do we talk here about the symmetry or not? Because I did, and then I was like, maybe not.
You have, they've seen that in geometry.
Okay. So you see, if this is x to y, right? And this one gives you the back relationship back y to x. You see how this makes these two functions symmetrical around this line y equals x. You see the symmetry in this, right? X to y, y to x. So you want to see the symmetry between going one direction and the other, right? Like there is this symmetry, right? So the graphs of the original function and the inverse function will be symmetrical around this y equals x because we are switching them places. Kind of intuitive, you can play with it, like just by looking at different functions and plotting, and you will see that it's exactly it. Okay? But we are not going to go into it too much. So that's kind of cool, I think. No? Not really. Okay. Let's try the next one. Parabola. Okay. So the original f of x, again, don't even need to overthink it too much. Just see for the original, my xy, I'll choose some good important points, so my vertex, -2, -4. My x-intercepts are kind of important, right? So -4 and 0, and then 0, 0. So I'll choose these 3 points, and they're enough for me to grab the parabola, right? So it should be enough for me to grab the inverse. So f -1x. What would be the corresponding points for the inverse? -4, -2, 0, -4, and 0, 0. Okay, so let's plot these points. -4, -2, -4, -2 right here. That's my new vertex. 0, -4 is right here, and then 0, 0 stays. So I just draw the line through these points.
How do you know it goes that way and not the other way? Oh, because it's the vertex, right? You can tell by the vertex.
Well, no, good question, right? But yeah, you can plot few more, for example, right? And you see, like these.
You know, you like the opening can face the other. Like what's?
Well, first of all, okay, 2 things, right? First of all, I already told you that it should be symmetrical around this line, always, right? So you see, it's kind of like flipping around this line, symmetrical.
So okay, so that.
That's the first thing, right? But even if you don't remember or didn't register that, see all of these points will have what coordinates? Positive x and positive y's, right?
Yeah.
Always. So there should be the corresponding all positives.
Okay.
Right?
So if it was like down, it would be going.
Yeah. So just since all of these will be they have negative x, positive y, so it has to be reversed. Positive x, negative y.
Okay, so say the original f of x, instead of facing up like it is right now, it's facing down, then the inverse becomes, okay, I see. Right.
So just like play around with numbers, make sense of it. Good? Questions? No? Do the next one on your own. This one is interesting. Yes. Just do this. Okay, so the original function, let's choose few points. And because it's a curve, pick more than 2 points, right? It requires more than 2. So let's just pick nice ones, right? So the x-intercept looks nice enough. So that's, what is it, 0, 3. The next one looks nice enough, 1, 4.
Or is that the y-intercept?
Y-intercept, I'm sorry. Y-intercept. And then the next nice one is probably 4, 5. So now to reverse function. So f -1x. All I need to do is flip them. So 3, 0, 4, 1, and then 5, 4. By the way, if you remember that symmetry, right, there is your line right here, has to be symmetrical around the line. So something like this should be there, right?
Wait, so it'd be coming through
Symmetrical.
the line?
Yeah, so see, this is looks like this. So if I draw my line of symmetry for all of those inverses, should look something like this, right? Something like around. That's some reference. Never mind. Okay, so using my point, I'll just plot them. So 3, 0 is right here, 4, 1 is right here, and then 5, 4, 1, 2, 3, 4 right here. So all I need to do is connect them and continue the shape. That's the shape.
Oh, okay,
That's how you inverse it. Questions? No questions? Good. They're done with today's lesson.